Hello, today we come to talk about waste-heat recovery boilers. The members of the groups are Laura Necera Rodríguez, Catalina Supiñán Gutiérrez, Nicolás Sánchez, María Paula Rochancel, Daniela García Moreno. Introduction. We will start talking about what is waste-heat recovery. The recovery of residual heat is in the process where the heat is integrated. This means that the thermal energy that will be eliminated or released into the atmosphere is reduced. This thermal energy is in the product of a process. By recovering this waste heat, plants in industries can reduce energy consumption and CO2 emission. It had two fundamental objectives. The number one, collect and distribute the heat to reduce it in the same equipment or in others. Number two, reduce the fluid emission temperature so as to reduce the thermal pollution of the plant.
Harvest line. The lines for the use of residual heat are mainly two. The first is the recovery of waste heat from the gases, where it saw to a achieve a decrease of 20 degrees Celsius in the emission temperatures of the gases implies an increase in the energy efficiency of a boiler of 1%. Since the combustion gas come out very hot, the possible reduction in temperature is great, achieving significant saving. The second harvest line is recovery of residual heat from other fluids. This point includes the use of heat from hot wastewater from equipment cooling processes. The possibility of use and temperatures are much lower than in the case of combustion gases. In the combustion gas recoverers, they are basically be divided in two types, economizer and aerator. The first is boiler economizers, in which water is heated with the heat of the gases. They transfer the heat from the gases to an air stream, generally used as an auxiliary for another combustion process. They are basically made of a boiler of conventional groove tubes, inside which the water to be heated circulates while the combustion gases beat the out surface. The tubes have four fundamental conformations which make them suitable for one of another functions. The first tube is AESA, drawing steel without fins. They are used in general when the temperature for the gases is very high, with large thermal jump between the tube's walls and large heat transfer. And the second tube is AA, stainless steel with transverse steel fins that are used in any heat transfer process as long as there is no risk of acid spray corrosion. F-pipes cause iron with fins. They are obtained by direct testing of the face. Greater resistance to corrosion than steel, up to 20 times heater. They are the most widely used in parts, but their use in the clean stop to their low mechanical resistance, which makes them useful for economizer with vapor. And finally, 8F tubes, made of strong steel covered with cast iron parts. They combine the mechanical strength of the steel with the corrosion resistance of the iron content. They are the most used today. And about the phenomenon of acid spray, the following minimum temperatures must be operated in this case For steel cold tubes A, ESA or AA, 160 to 170 degrees Celsius to 120 to 130 degrees Celsius, and for iron cooled tubes F and AF 50 to 160 degrees Celsius and 70 to 80 degrees Celsius. And the other is aerator. It is an important auxiliary equipment in industrial boiler and furnace works by recovering the sensible heat from the exhausted gases. But to be resourced in the equipment itself, it should take to another area of the plant. Preheating the water has the following effect. First, heat losses in combustion gases are reduced, saving approximately 1% well of every 20 degrees Celsius reduction in the temperature of these gases. It increases the flame temperatures in the combustion zones, increases the heat transfer by reduction in the amount of steam. The second is produced with less excess combustion, and maybe some fuels can only be burned with air preheating such as coal. The different cares that should be taken in this process are the first, acid dew. In the combustion process, the sulfur contained in the fuel is oxidized to sulfur dioxide, which can be further oxidized to sulfur dioxide, having a great tendency to combine with water to form sulfuric acid, which remains dissolved in the water with great power corrosive. If the temperatures drop too low, the dew points of this solution can be resin, condensing drops of high concentration due to equilibrium. The acid dome phenomenon makes it necessary to reach an optimal value for the reduction of the gas temperature, balancing the energy saving of recovering more heat with the expensive of reducing the useful life of the tubes due corrosion. And the second case is latent heat and sensible heat. First, and the sensible heat is the heat used to vary the temperatures of a body, in this case were of thermal fluid, and it is relative to a specific heat. And finally, the latent heat is the heat used to produce a share of the stand in the body, such as the evaporation of water. Use latent heat of evaporation condition to the water is 500 parts.
In this part, I'm gonna talk about the B-transfer heat exchanger. This heat exchanger doesn't transmit heat through a gas but uses a carrier fluid with the necessary energy to heat the other fluid. It is used when direct contact between the two fluids is not possible, so it's necessary to use pipes so the fluids don't mix it. This exchanger allows the heat transfer over long distances. In this one, the carrier fluid, the selection of the heat transfer fluids that should be used from the previous system has a selectivity criterion and is thought about the temperature. When the temperature is less than 200 degrees Celsius, water is used as the carrier fluid, but when the temperature is greater than 200 degrees Celsius, a thermal oil is used for the heat transfer. The vapor condenser in dryers. These gases from the dryers come out at a high temperature and with a high degree of humidity, so that both sensibly heat and latent heat of condensation can be recovered. This system works in two ways. The first one is the direct method, where there is a mixture between the fluids. Therefore, there is a reaction that reaches the chemical equilibrium. The last one is the indirect method, where the heat exchange occurs that through pipes so that the fluids don't mix. Additionally, part of the humidity of these gases condenses. It is for this reason that the use of a water collection system is necessary. In this part, in the thermal tubes, this system is set of two sealed concentric tubes. The liquid moves of capillarity. This system is divided in two parts, the cool side and the hot side. One of the parts of the system is heated to evaporate the fluid and it evaporates to transfer the heat to cooled fluid where part of the vapor condenses. In this part, the types of heaters. This one, I'm gonna explain this type of exchanger to you through a video. The tubes are located and divided among themselves through deflectors so that there is no contact between them. Then the system are covered by a shell and the system is completely sealed. The next part is about the fluids then pass through the system in a counter current transferring energy from the warmer to the cooler fluid, as shown in the video. The next one type of heater is the extended surfaces. This one they use is to reduce the volume of the heater. Heat transfer by conduction, convection, and radiation, and the contact area increases, allowing greater heat transfer by increasing the transfer rate. And these one are four types of extended surfaces. In this one, in the third type of heater, the borosilicate glass. This type of heat exchanger has the following advantage: is used by gases at a low temperature, no flex are, it has a low roughness, and the corrosion is resistant. But at the same time, it had some disadvantages like glass fragility and dilatation at a high temperatures. The next one is the refractory steel. For high temperatures, keep temperature constant and not suitable for discontinuous ovens. The transfer of heat is through conduction and radiation. This one, the regenerator. This type of heat exchanger has the particularity that there must be preheating of the fluid, which is then stored in the heater and the cooled fluid will rotate through a rotation system that allows the contact of the cold fluid with the hot fluid, homogenizing heat transfer throughout the system. And the last one, we have the heat pump that recovers the heat of the hot water, temperatures between 55 and 65 degrees Celsius. This has reached a lot of strength in recent years, since it's friendly to the environment and is also very profitable for places where there are change seasons, since the heat pump serves both to cool and heat interiors. When the system is cooling, the heat that is thrown outside could be used by another process that needs that energy.
Typical example of residual heat recovery. Number 1. Waste heat boiler WHB. These are responsible for recovering the heat generated in ovens or exothermic chemical reaction in industrial plants. This recovering energy can generate low to medium pressure steam or hot water. The steam generated at WHB can be used for heating application or to drive turbines that generate electricity, compressed vapor, or pump liquids. A WHB can also be used to remove heat from a process fluid that needs to be refrigerated for transport or storage, and generate steam from that heat. Second, heat recovery steam generation, HRSG. Heat recovery steam generation provides the thermodynamic link between gas turbine and steam turbine in a combined cycle power plant that use a jet line to generate electricity and then generate steam from waste heat. The HRSG are cost-effectively designed for heavy cycle operations that allow industries to reduce the cost of electric recovery steam generation. Have two types. The first type is the horizontal, that is this, that save exhaust gases flow horizontally over vertical pipes. And the other type is vertical type, that exhaust gases flow vertically from horizontal pipes. HRSG is important the pressure levels must be taken into account, such as number 1, single pressures, they have a single steam drum and steam is generated at a single pressure level. And number 2, multiple pressures, they have 2 double stream or 3 triple stream steam drums. Number 3, absorption chiller. In this slide, show in detail step by step. Then I will explain with the diagram. Number 1, the diluted absorbent liquid is preheated with condensate as it travels from the absorbent to the generator. Number 2, in the generator, the absorbent liquid is heated with steam, which causes some of the water contained into a vaporize, making the liquid more concentrated. Number 3, the concentrated absorbent liquid flows down back to the absorbent to capture more water in its continuous loop. At the same time, the water vapor moves toward to the condenser. Number 4, in the condenser, the cooling water causes the steam to liquidly and flow down towards the evaporator, which has a pressure close to vacuum. Number 5. Just before entering the evaporator, the condensed water flows through an orifice or expansion valve. This restriction limits the flow, and the water again vaporizes to a cool mid at 4.5 degrees Celsius. This is where the cooling takes place. The steam lowers the temperature and extracts the heat from the shallow water circuit, reducing its temperature by approximately 5 degrees Celsius. Number 6. The mix heat up when it absorbs heat from the shallow water circuit. But the strong attraction of the concentrate safe solution pushes the water towards the concentrate absorbent, creating never vacuum pressure of the evaporation in the process. Number 4, steam thermocompression. The steam Thermocompression uses energy in a stream that would otherwise be lost, such as low-pressure steam. This is the process of mixing high pressure and low pressures to create an intermediate pressure steam using steam compression equipment like TLBS system. The compressed steam is pushed into a chamber with a lower temperature, and consequently it condenses. To this is given up this heat of evaporation to the liquid contained in the condenser, and the liquid evaporates in an amount that corresponds to the weight of the condenser vapor.
Other examples of waste heat recovery in steam system. First, flash steam separation and reuse. Second, boiler purge. Third, steam well air. Flash steam separation and reuse. Flash steam is an enemy given to the steam that forms from hot condensate when there is a reduction in pressure. In the installation of pressurized flash or flash separation tank, the flash tank recovers condensate discharged from the steam traps and allows the steam to be diverted into a low-pressure line for reuse in other processes that require it. However, a flash steam recovery system results in a great amount of back pressure. Care must be taken to maintain the necessary pressure difference at the top so that the steam traps can continue to operate. In addition, there must also be a real need for the use of a low or medium pressure steam provided by the flash tank. Sometimes the pressure of the recovered flash steam is below the minimum pressure or temperature required for use. In the flash steam pressure reactor, a mixture of one bar, the steam can be discharged to the atmosphere inside of begin reused because the pressure is simply not high enough to meet the process conditions. Since the minimum pressures is too bar, the steam can be reused. To avoid this, a steam injector is used that uses thermocompression to mix the flows of two different pressures, delivering steam at a medium pressure between those of the inlet flows to the ejector. This is what makes it possible to raise the flash steam pressure to usable levels. Second, boiler purge. Boiler feed water contains dissolved soils, both from water and chemicals from treatment. During evaporation, the concentration of total dissolved soils (TDAs) in the boiler increases. If not controlled, foaming will occur in the steam space. Carryover and contamination of the steam transport by the system. These products are deposited on the heating surface and auxiliary equipment affecting the efficiency and productivity of the plant. The problem can be solved by keeping the TDA's level close to that recommended by the boiler manufacturer, usually between 2,500 and 3,000 ppm for a medium-sized boiler. The purge is achieved by opening a large valve at the bottom of the boiler of a few seconds. This allows a large amount of water and solids to be removed under boiler pressure and introduced to a purge line, a purge tank, especially designed to allow the mixture to cool down before drying. It's recommended to use and automatic control since less water, fuel, and chemicals are required. Less maintenance, therefore less repair cost. It requires less supervision. In addition, it improves plant efficiency and health recovery. Available systems are some of the system uses for BCS3, BCS2, BCS1, and BCS4. Steam water heat. Low pressure steam can be used to make hot water for process or domestic use. If the supply of steam from a wet heat is not continuous, the supply steam can be kept constant by using a supplement steam value. Hot water supply for the food industry, chemical and pharmaceutical manufacturing, and building technology.
Efficient measures related to design. Dimension the gas conduits according to the Mason gas flow rate and grade them according to the usual recommendations to avoid pressure losses due to excessive friction. Adapt the type of recovery boiler eh, according to the content of solids in the combustion gases. User economizers and user superheaters of recovery heats if the temperature of the gas is sufficient. Efficient measure related to operation. Reduce the temperature of the combustion gases as much as possible. Avoid the corrosion with spray acid formation. Carry out of combustion with the minimum amount of air compatible with the environmental conditions of the stage of the facilities. Use additives that prevent the incrustations in the water piece and equipment cause the hinder the transmission of heat. And preheat the combustion air in combustion process. Okay, the efficient measure related to clean and maintenance. Keep the exchange superficies free of soot and incrustations by blowing steam, compressed air or washing with hot water. This is to prevent the avoid thermal shocks. Carry out maintenance of closures and joints to avoid the pressure losses in the pipes. Head insulation the following parts to minimize head losses in ceramic fiber insulation recommended. And clean the economizers and exterior of heat exchanger in general. Criteria for choosing the proper type of boiler. Choose criteria for pivot boilers. This is a boiler and have the furnace, the smoke base, the hot gases and steam out. These are used to take advantage of hot gases or liquids at high temperatures. They are used for gases at high pressures up to 25 atmospheres. They are usually used in cases where it is possible to ship the complete and finished boiler to factory. They are in general easier to clean and less susceptible to fouling than water tubes. In both types can be used the fire tuber is cheap. Generally, this is a greater pressure drop in gases than in water tubes. Okay. Choose the criteria for water tubes boilers. They can be designed for any pressure. Smooth tubes or tubes with fines over specific sulfurs can be used. When gases create low transfer or when only a small pressure drops is a possible, they perform better than fire tubes. They are most useful from gases at high temperature and low pressure. Can they be assembled according to the needs and availability in the factory? They are not recommended when the impurities in the gases are very increasing due to the difficulty of blow. Fewer mechanical filters occur in them than in fire tubes. It is possible to boil them with a natural circulation and with forced circulation. Certain water tube design can be built with a superheat, air and economizer. Okay, this is the parts of a tube boiler, boilers. This is a furnace, the water pits, the steam out, and the hot gases. Advantage and disadvantage of recovery boilers. The use of these recovery boilers has important advantage among we can mention. Okay, the heat exchange process in recovery boilers is one of the highest performance. Recovery boilers require a lower investment than in other heat recovery systems because they don't have a fireplace with a burner. The control in this boiler is easy, based on demand and steam pressure. Okay, these are the disadvantage. When using water steam as the carrier fluid, a high quality of the feed water is required. In general, it's not possible to lower the temperature of the gases sufficiently. Consequently, an additional system is required to recover the less sensible heat in gases leaving the boat. Okay, this is a boiler technical regulation of Ministry of Labor, Ministry of Mines and Energy. In the chapter 1, the name of the chapter is the junior disposition and article 1 is the objective that have three parts: requirements, a recovery system, the system control, and the security. In the chapter 3, and the name of this chapter is Basic Requirements of Design and Manufacture Control Indication, Device, and Other Missions of Safety and Protection of the Boilers. Article 21.1 is the boiler design basic standards. Article 21.3.1 permissible stress limits. Uh, Article 21.3.2 element calculations. Um, Article 21.3.3 Material Specifications and Article 21.3.4 Minimum Estimates. These articles rule over the International Asmet Code. And the chapter 4, the boiler operation and maintenance is we have two articles. Article 50 maintenance of boilers, and 5.1 prevent maintenance of boilers. Um, in these articles, we can talk about of the shape region's temperature, outlet of boiler, and the level of water.